Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. In the previous video we looked at correlation and we concluded that chapter, and today we want to start off by looking at a new chapter, that is regression or regression analysis, and this is chapter 19, regression analysis or regression. Of course, by the end of this chapter, you will be able to explain the individual terms used in what we call simple linear regression models. That will be our learning outcome number one. So the focus is all about simple linear regression models. The other objective is that we will be able to determine, using the least squares regression method, we'll be able to get the least squares regression equation. And of course, the other objective is for us to be able to make what we call point estimates for the dependent variable. These are some of the things that the point estimate, these are some of the things that we shall look at when we are dealing with confidential intervals, things to do with estimation and confidential intervals. Now, I want us to look at what do we mean by regression first of all. Regression or regression analysis, it does what? Of course, regression, or what you call regression analysis, is a statistical technique, is a statistical technique used to study the relationship between one dependent or what we call response, one dependent or response variable, and one or more independent variable. The independent variable, they are also called predictor or explanatory variable. Now, the whole idea is for us to focus on one dependent variable, but the independent variable can be more than one, or the explanatory or the predictor variables. So it helps us to determine how changes in the predictor or in the independent variables affect the response or the dependent variable. So if there are changes in the dependent variables, how are they going to affect the dependent variable? Now, of course, how this happens is that once we have drawn our scatter plots, like the way we drew them in the previous video, these scatter plots, they always show a straight line relationship between the two quantitative variables. Now we are talking about one being dependent and one being independent. Now, the moment that we have a straight line relationship or a linear relationship between the two quantitative variables, as per the graph, now what we do, we always want to summarize the overall pattern of these different values by plotting or by fitting a line to the data set that we have. In other words, we always want to make sure that we draw a line. Now, a regression line is a straight line that describes how the dependent variable y changes as the explanatory or as the dependent variable x changes. In other words, it's just a mathematical equation that describes the relationship of the two variables, the independent and then the dependent variables. So, once we have drawn our scatter plots, it's always important for us to draw what you call a line of best fit. A line of best fit. We are going to, if time allows, we shall look at how can we practically draw it without just, because there are two options of drawing a line of best fit. You can just assume and then you draw, as long as it cuts most of the points. It cuts, let's say, in the middle, halfway, the values. But we shall get to a computational moment where we can know exactly how to compute, how we can basically compute that line of best fit, even though it's not so much examinable, especially drawing the line of best fit. They always bring the question, but the question always wants you to find the line, the equation of the line. Now, that line of best fit, the line that fits those different data sets, that line is a straight line, is what we call the regression line. And since it is a straight line, it takes a form of y equal to a plus bx, whereby this y is representing our dependent variable, dependent or response variable, dependent or response variable. Then our x represents the independent variable, or what you call explanatory variable. Then, of course, This B represents the slope or the gradient of the line. And of course A represents the this A represents the y-intercept. The y-intercept. What do we mean by y-intercept? The y-intercept, which is the value that you get when x is 0. Of course, if x is 0, it means 0 times b, it will be a 0. So that the y will be equal to A. So we look at that intercept when the x or when the independent variable is 0, what will be our y? That is what we call the y-intercept. Now, this regression or regression analysis, it gives us a way of analyzing the relationship between one dependent variable, or what we call the response variable, and one or more independent variable, or what we call the predictor variable. So you have to get all the names. Now, a line of best fit, most of the times we draw it by just using our eyes. We just draw using our eyes. So it is always going to be dependent upon the subjective judgment of the person who draws it. So you take as long as it cuts across most of the plots that you have made. Now the consequence is that the position of the line of best fit will differ a little bit slightly from one person to another, because you are just going to assume this is what is mostly done. But I told you there are steps that we can follow to draw an accurate line of best fit. So a line of best fit will be the one that will give us what we call the regression line, as I said. So a regression line is just a straight line that describes how the dependent variable y changes as an independent variable x changes. Now, of course, as I told you, regression analysis is used in statistics, or it is a statistical tool that is used in different areas, like in areas of economics, areas of business, areas of engineering, areas of medicine, areas of agriculture, areas of education, finance, and even social science. So we use regression analysis to get the relationship between different variables. But of course, you need to understand that regression and correlation, those are two different concepts, even though they may look a little bit similar. Now, if you look at correlation, we went through correlation, and when we are looking at correlation, we had no distinctions like it wasn't so much important for us to differentiate between the dependent and the independent variable. We could just give any value x and any value we give it y, which is not the case with the regulation, because regulation you have to be able, you must be able to know which of these variable is dependent and which of these variable is independent. So the distinction between dependent and explanatory variables is very crucial, or it's very important for us to be able to differentiate among the given variables. Then the other differentiating feature between correlation and regression is that the relationship, if we are dealing with correlation, the relationship between the items or the variables that have been given to us, we just look at that relationship when we have only two variables. So the relationship is between two variables, but this side we can predict a particular value of y for a specific value of x as regression is concerned. So the other side we can have more than one. Then of course the third way to differentiate between correlation and regression is that if you look at correlation, we try to measure the strength or the degree of linear relationship between the two variables. But here, most of the times you find that we are going to estimate the mean value of the dependent variable for a given value of x. Of course, before we look at the different forms of regression, but remember, in our study objective, we said that our focus is going to be on simple linear regression models. But that doesn't mean that when you're dealing with regression, it's only about those ones alone. We have different forms. So before we look at the forms, let's maybe first focus on the application of regression analysis. Of course, the application, we've said that there are very many different items where we can apply regression. Of course, we said we can use it in business. You can use it in business, and of course, when you're when you're handling it in business, you can look at what we call sales forecasts. Sales forecasts or sales forecasting. You can also use it in demand analysis. Demand analysis, where we can look at maybe the price vis-a-vis the demand for the product. Of course, we can also use it in determining the effectiveness of the advertisement, advertising effectiveness. You look at the money you are spending vis-a-vis the sales that you are getting to know whether you are utilizing the money on the adverts. Of course, we have areas of economics. And of course, in areas of economics, we can use it in, let's say, inflation prediction. When you're predicting inflation prediction, we can also use it to estimate our GDP, gross domestic product, so GDP estimation. We can also look at the consumer expenditure analysis. Those that are dealing in medicine, they can use it in predicting the disease risk. They can also use it in maybe predicting or looking at the patient's recovery time and also maybe drug efficiency. Those in agriculture, they can use it maybe to cut out crop yield prediction. Then also they can look at the rainfall analysis. They can also use it in fertilizer effectiveness. You look at the fertilizers you have applied, then you try to compare with the outcomes, so that you know whether the money you've actually spent on the fertilizer is actually giving you the maximum yield or the maximum desired production. In engineering, of course, they can use it in quality control, reliability studies, even in machine performance predictions. And of course, in education, we use it maybe in looking at the students' performance. Of course, you can also use it to identify the various factors that can lead for maybe for students to achieve whatever they have achieved. If students are performing badly, we can use regression analysis to analyze whether it is maybe because they didn't attend their lectures, or was it because they didn't revise? Was it because there are some technicalities that happened and maybe students were unable to finalize their syllabuses? So those are some of the things that you can look at and be able to know the application, because it is also important for us to understand where we are going to apply some of the things that we talk about. Of course, maybe to highlight some of the dependent variables. The dependent variable is the one that we call the response variable. Some of these, of course, these variables, the dependent variables, they are the outcome variables that the researcher wants to predict or explain. You want to look at what has come out, the outcome variable of the experiment you are trying to carry out. Some of the things, it could be incomes, it could be sales, it could be crop yield, it could be blood pressure, and all other items. But the independent variables, of course, these are the explanatory variables. These are the ones that are used to predict the dependency or the dependent variables. In other words, they are the ones that if they change, they can cause a change into the other outcome. For example, you can look at the educational levels, can you look at the advertising expenses or advertising expenditure. We can look at the age. Maybe if you are trying to get the performance of the student, and maybe you assess based on their age. Can have maybe rainfall. So those are some of the things that you need to understand as far as regression analysis is concerned. Of course, you have also to know the uses of regression. Of course, mainly we use it in carrying out what we call predictions. Now, I want us to look at the forms of regression. Forms of regression analysis or forms of regression. Forms of regression. We have very many, but we are going to talk about, I think, two. There are very many regression analysis. Maybe you can highlight them, but as far as CPA syllabus is concerned, we are only going to look at only two. Maybe to list them just for your information, to have an understanding, or to recognize the fact that they are not only two. So the first one, we have what we call the simple linear regression. Simple linear regression. Simple linear regression. The second one is multiple linear regression or multilinear. Some books, they may call it multilinear regression. But we also have what we call the polynomial. These are the ones that are in a curve. These are the curvilinear regression. Our emphasis is to look at these two, but even these two, we may not, as far as this syllabus is concerned, we are going to just focus on the simple linear regression, but I just want us to have an understanding of the different types. Of course, if you are doing statistics, as maybe if you're a statistics major, you'll have an understanding of all of these regression analysis. We've said there is polynomial. Now this is not linear. Polynomial regression, this is a curve. This one, all the models that within the polynomial are what we call curved relationship. Then the other one, we have what we call the logistic regression. Of course, this one, the logistic, is used when the dependent variable is categorical. These are some of the things that if you are doing maybe SPSS, or you are doing maybe starter, these are some of the things where you'll have things that are categorical in nature. We also have what we call lasso regression, and then the ridge regression, and then ridge regression. So these are some, but our main emphasis is just on this first one. The second one, the multilinear, we also talk about it because it has a linear relationship, and we may have questions where we have more than one independent variable. That's why we also talk about it. But the whole concept is the same. So we are going to look at the simple linear regression model because that's what we want to talk about as far as these quantitative techniques for CPA syllabus is concerned. So let's look at the simple simple linear regression. Simple linear regression analysis or simple linear regression model. And of course, this is a regression. This is a regression equation. This is a regression equation in which we have one independent variable and one outcome or the response or the dependent variable. So here we have only one independent variable and one dependent variable. So with this, it is the one where we have y equal to a plus bx. Then for the multiple linear regression is the one where we have multiple independent variable and one outcome or dependent variable. So we have said the dependent variable is our y value. Then x value is the independent variable. Now, of course, you'll find that most textbooks will try to use different letters. They may not use some of these letters, but as long as they explain, you'll find that some textbooks may say they are using, let's say alpha. They may use alpha and beta instead of using these values, but I prefer to use the simple values. Then the other thing is that other textbooks, of course, these are some of the things, there are so much that we don't talk about which are beyond the syllabus, but some textbooks, you'll find that they have written this as maybe y, let's say capital Y, and they have used maybe beta. This is beta naught plus beta 1 and capital X, then plus they put this symbol epsilon. This one is for an error. This E represents a random error. We may not go through some of these aspects, the error, but just know the moment you are making these estimations, you are not going to be 100% correct. That if we are determining some of these values, we may have errors, maybe with the data, so that kind of error that they put. But most of the times for us, we always assume that we have no error and we exclude this part. So whichever letters they have used, because this beta 1 will be the slope, and then the beta naught will be the intercept, and then the y will be the dependent variable, and x will be the independent variable. So whatever they have used, so when you meet a textbook that has an equation like this, just know that extra item they have added is just the is just the error. You can call it a standard error, you can call it anything, but it is just an error. Of course, now I want us to look at the methods. Methods of determining a regression equation or a regression line. Because we are always interested in having this line. As I said, some textbook may just write it y equal to a plus bx, as if it is just the equation that we use when we are dealing with the costs. So, of course, we have very many methods, as we have seen. We have the method of drawing the line of best fit. That is our first method, but I prefer to go through the least squares approach, the least squares method, because that's a second method that we can use to determine the regression line, and that's one that is most preferred. I'm not taking it because I want to start with it, but I'm taking it because it's the method that is most preferred. But you also have to understand the other method. And of course, in the process of getting the regression line, that one is very easy. I told you, you can draw it using just mere eyes, then you draw the line. But we've said there are ways where you can go through to be able to get a perfect line, and we draw it very well. So I want us to start with what you call the least squares. Least squares approach or method. So when you are drawing the line of best fit, of course, an attempt is always made to minimize the total divergence of the points from the line of from the line of best fit or from the line. But as we are computing the line mathematically, the same idea is also pursued. With this same method, the logical method known as the least squares method. And of course, when you are using this method, we always look at these aspects, then we try to get, depending on what they are asking. Of course, I told you have to be able to know which one is the dependent and which one is the independent variable in whatever items or in whatever variables that the examiner has given you. But you should also, at some point, they may not, maybe it may be hard for you to know that this is dependent or this is independent. But you may look at the examiner may tell you to predict some variables, because in the examiner can tell you to get the equation of the line, and at the same time he tells you to predict a certain variable when he has given to you another variable. You can say predict the y values when he has given you the x. So the implication is that we are predicting the y on x. So you can look at the question that the examiner has given to you. It can tell you to predict maybe y on x when he has given you the x value, but he wants to know the y value. So that can be another way of identifying which one is going to be our dependent and which one is going to be our independent variable. So we want to look at two situations when we are predicting y, predicting y on x. In other words, when we have the x, when you have the x value but you want to get the y value. Of course, in this, the regression line, the same, we are going to use the same approach, that we are making the same equation y equal to a plus bx. So there are situations where you can say that I'm going to just solve these items. You can have two equations. You can say summation y is equal to our a times n plus b summation x. That can be our equation 1. Then equation 2 can be summation xy equaling to a summation x plus b summation x squared. Those are the two items that you can use to solve. You solve them simultaneously. But the least square method helps you to get the item B. It helps you to get the slope. It helps you to get the slope, and it also helps you to get the A and B. You get the intercept. The least squares looks at the B will give, it will be n summation xy minus summation x times summation y over n summation x squared minus summation x bracket squared. And our A is equivalent to y bar, that's the mean, minus b x bar, or you can say summation y over n minus b summation x over n. Whichever you choose to go with will be giving you the same answers. So we do it the same way we did with the correlation. We get our x, y, and then we get x squared, and that's it. We also get summation x and summation y. Then we substitute in the formulas, we get the other values, and then we substitute in those equations to give us the values. So those first two equations that I have written up there, if you try to do the mathematics and you solve them simultaneous, you'll be getting these methods. You handle those two methods and then you solve them simultaneous, you'll be getting, whether you use substitution and you substitute, then you end up with this. So this is the least squares method. This is what you need for any number. Now, I want us to also have the other argument when we are predicting some of the things. You may not pick them right away, but when you are doing predicting x on y, when you've been given y value, but now you're looking for x. So if the desired answer is for you to get the x value when they have been given to you the y, this is like the second regression line, that is the regression line of x on y. It's only necessary to just alter the two simultaneous equations so that we can be able to get the x's and then the y's as the intercepts. So this one, the equation, of course, the equation is going to be summation x equal to an plus b. We are just altering, we are changing summation y. Now here the x value is the one that is starting. So this will be, maybe can call it equation 3. Then this one will be summation xy equal to a summation y plus b summation y squared. This is equation 4. Of course, if you solve this, it will also come up with this. It will be giving you these a and then the b values. But the moment you keep on practicing, you'll see when you are doing numbers that you can, of course, decide to use just one method, then you keep interchanging in the values. You will see when you are, because once you have gotten the regression line, the regression equation, then you can substitute in any value. But of course, this side, I'm just giving you scenarios of how you can identify. So b is equivalent to it is the same summation x1 xy minus summation x summation y over n summation x squared minus summation x bracket squared, and our a will be now the x bar minus b y bar, or summation x over n minus b summation y over n. Our n is the number of values. So maybe you can have a smaller simulation to help us understand, and then we'll be able to get the equation. But what is very important for us is that we have to know exactly how to interpret the results that we have got. Let's just use a small data set to just help ourselves to understand this. Example, using the table below, comma, describe the simple regression line. So let's have the data set x, y. Here I've given to you the values, but in the question they may give you sales, they may give you expenditures, so it's up to you to know which one is which. Because the moment you fail to know, this is 2, this is 60, maybe this is 5 and 100, this is 4 and 770, this is 6 and 90, and 3 and 80. So let's look at the solution. So we substitute in these values. Start with the x values. This is 2, 5, 4, 6, and 3. Then the y value, this is 60, this is 100, this is 70, 90, and then 80. Of course, we shall add those values. Then we need our xy. Then we need y squared. So of course summation here, the summation of x, summation x 2 plus 5 plus 4 plus 6 plus 3 equals 20. This one is 20. That is 20. Then summation y, summation y equals 400. Then we get this 2 times 6, 2 times 60, that is 120. 5 times 100, that is 500. 4 times 70, that is 280. 9 times 90 times 6, that is 540. 3 times 80, that is 240. If you add those, you'll be getting summation x as 1680. 1680. Then we get our y squared, 60 squared. If you want, you can actually get even, you can even get your x squared here, but it's not necessary. Y squared 60 squared, that is 3600. Then 100 squared, that is 10,000. 70 squared, that is 4900. 90 squared, that is 8100. Then 80 squared, that is 6400. When you add those, you'll be getting, when you add those values for y squared, you'll be getting 33,000. So you can add in the x values if you want. You use both methods. Because one of the method has summation x squared below and the other has summation y squared. That's why it is important you can be able to have these two aspects. You have even the x squared, you also put it there. Of course, x squared here, maybe you can just indicate them. This is 4, this is 25, this is 16, and this is 36, and this is 9. This one we are just putting it, but it's not all that necessary. 16, 25, 4, 36, and 9. It's 90. So you'll choose whatever, because here they have not specified for us. They have not specified for us which one to use. So we substitute this in the formula. And of course, we are going to look at when you are predicting x on y. Predicting x on y. This means that we are going to have the equation as x equal to a plus b y. That will be our equation. So, and our b will be n summation xy minus summation x summation y over n summation. Now this will be y squared because we are looking for, we have the value, then summation y bracket squared. And our a, of course our a will be equaling to x bar minus by bar. So we substitute in these. We start with b because we can't get a minus getting the b value. So the b will be equaling, of course, the number of values there are 4 into 1680 minus 20 times 400 over 5 into 33,000 minus 400 squared. And of course, once you put this in the calculator, you'll be getting 0.08. Then now we get the value for a. The value for a will be, the x bar will be 20 out of 5, which is a 4. Of course, this is x bar, let me call it x bar, which is a 4. And then the y bar will be equaling 400 divided by 5. That will give you 80. Then we substitute now into the other a. So you can get our x a value, and the a value will be, a will be equivalent, our x bar was 4. So it will be 4 minus 4 minus, now we are getting 0.08 times 80. So that will give you a negative, A will be negative 2.4. So we substitute in our equation, this equation. We have gotten the A value, we have gotten the B value. So we substitute in the equation to get the equation of the line. So when you substitute in the equation, you'll find that you'll have negative 2.4 plus 0.08 y. So x will be equal to negative 2.4 plus 0.08 y. That will be the equation of the line if we are predicting x on y. So I want us to do the other alternative you find. Of course, now we have to explain. Before we do the alternative aspect, you have to interpret the result. Now, when you're interpreting the result, this negative 2.4, it implies that the negative 2.4 will be the x-intercept when y equal to 0. In other words, 2.4 will be the value of x when y equal to 0. Or it will be a point, it will be a point where the regression line will cut the x-axis. Then the other aspect that you have to explain is this 0.08. And that 0.08, we said it is the slope. In other words, that's the rate of change in x per unit change in y. So the simple linear regression equation of x equal to negative 2.4 plus 0.08 y can be used to predict the values of x for any given value of y. So that rate of change, or the slope, it gives you the rate at which the x will change to give you it will give you the rate of change of x per unit. It gives you the rate of change in x per unit change in the other variable. So we said the regression equation will actually be equaling to x equal to negative 2.4 plus 0.08 y. In other words, if I want to get an x value, if maybe y is, let's say, 1, you will get the value. If maybe the y, of course, the y value has to be estimated depending on the value. Like, you can't give 1 because the y values were starting, the minimum value was 60. So if let's say it was, let's say 65, if y value was 65, this x value will actually be negative 2.4 plus 0.08 times 65, and that gives you a 7.2. Now I want us to assume that we are predicting y on x. The interpretation of this will be that the equation will be y equal to a plus bx. But the other one was x equal to a plus. It is just an interchange of the values. And what happens to be the independent here will be the one that will be on our numerator. So the b value will be n summation x y minus summation x summation y over n summation x squared. The other time we had y squared, this is x squared minus summation x bracket squared. And then our a will be equaling to y bar minus b x bar. So that's the formula that we are going to use. And you'll see whether we are going to have either different value or we are going to have the same value. So what is going to change is only the denominator, but the numerator will remain the same for that b value. The other thing that I forgot to talk about in correlation, I've got a question and someone was asking about Kendall's rank correlation coefficient. The other side we have both the Spearman and then the Kendall's rank correlation coefficient. We shall look at that. It's a very simple aspect to do with ranking under correlation. We shall look at it. I saw it as if it was examined in the previous sitting this year. So it is something that of course we must also highlight since it was examined in that paper, the Kendall's rank correlation. So let's look at our b value, which is the same 5 into 1680 minus 20 into 20 times 400 over 5 into, now our summation x squared, we got it as 90 summation x squared minus our summation x bracket squared is 20 squared. So this one is giving us, this is 80, the numerator. Let me try to simplify. The numerator minus this is 8,000 over 45, 450 minus 400. So this is 400 over 50. You will see that here we are getting 8. The other side we gotten 0.08. This time round we are getting 8. Our A will be, now this one is will be summation y over n minus b summation x over n, which is our summation x is 400, summation y is 400 over 5 minus 8 into summation x is 20 out of 5, 20 over 4. So the first one is 8. This is 80 minus, this is giving us 80 minus minus 32. That gives us our A is equivalent to 48. So we write our equation of course we write our equation as y equal to, our A is 48 plus 8x, 48 plus 8x. That is the equation. So you have to be very careful to know. Now this one will help you to determine all the y values when you have been given any value for the x values. So I want us to look at now the second method of having a line of best fit. Remember, when you draw the line of best fit, these other values, if they tell you to get these other values, you just plot that value they have told you. If the value is on x-axis, you draw that line. When it touches that line of best fit, you draw to the horizontal, and then you read the value that is there. So I want us to know how we can draw, and still we do it in the same way we have done this. When we are predicting y on x, we do it differently from when we are predicting x from y. So given the fact I was going to skip this method, but given the fact that last year they examined Kendall's rank correlation, it has not been common. But since it was examined, we need to understand the trend and explain some of these aspects beyond what the examiner, so that we cover all the loopholes where the examiner can maybe pick a question. Of course, it is the same method. I will explain one, deeply explain one, then the other one I will just show you what to do. Because if I explain predicting y on x, then predicting x on y will be very easy. So let's look at the second method as a method of drawing a line of best fit. Line of best fit. Of course, specifically we want to predict. This is for predicting y from x. You actually if we are to see the graphical aspect, you are going to understand why we are giving these methods different. Now, one thing that I want us to get, or one of the assumptions they make when they are drawing the line of best fit, is the fact that they assume that all the values of x are going to be accurate. Because remember, we are determining y from x. So the assumption is that these values are actually accurate. The values of x from which we use to determine the y value, they are accurate. The reason why they are giving you that assumption is because we saw in the method, in the linear regression line, that they always put an error. That's why the other error we assume it is a 0, because they always assume that those values are actually accurate. So that's the first assumption. You can as well write it there for the examiner, that we assuming, because if you don't assume, then we are not sure that the values we are going to get will be correct, because the errors that may happen in the data set. So we assume the values of X are accurate. We only assume the values of X because it is the one that we are using to predict the Y value. Now the first step, step one is for us to find the mean. We can call it capital M, mean, for both values X bar and then Y bar. Mean of the distribution. Mean of the distribution. In other words, mean for the two values, whereby X bar will be equaling to summation X over N, and Y bar will be equaling to summation Y over N. That is the first step. Now, the other thing you have to understand is that when they say we are predicting Y from X, it means that Y is on our Y-axis and X is on the X-axis. That is the implication. Now, after getting the mean of the two pairs, these means are going to be used as if they are coordinates. You have been given the data set. You have gone ahead to plot. Remember, by the time you do this, you must have plotted all these values. You must have plotted. You make sure that you first plot all the values that have been given to you. You use those values, the pairs, X and then the Y. You plot them the way they have been given to you. Then these steps, they come when you have already done the plotting. I hope you are getting what I'm saying. You first plot the scatter diagram, or you have the scatter plot. These steps come when you have already plotted the observations that have been given to you in the question. Now, of course, once you are done, that M, or the mean that you have first gotten, we can assume that that is our general mean. That is the general average of those different items. Now, the second step is for us to plot the M. This capital M is the other mean. Let me just put X bar, comma Y bar. They are going to be read as if they are coordinates. Plot X and Y, X bar and Y bar. In other words, plot the mean of those two means. And through that point, through M, You plot and label it as point, as M, letter M, capital M. And now through M, you draw a line, you draw a line parallel to the y-axis. It is not going to be parallel to the x-axis. Actually, this step is the one that differentiates when you are predicting y values from x values. Because for this one, if you are dealing with x from y, you draw a line parallel to the x-axis. You know parallel lines, these are lines that never meet. The reason why we are saying you draw a line parallel to the y-axis, because the y-axis is the vertical axis. So if you draw a line that is piercing from that point of the mean that you plotted, the x bar of x values and then the y bar of the y values, you draw it and it dissects the different coordinates. You don't care where that point is going to cut, but just know that straight line that you have drawn, it will cut these plots into equal plots. What do I mean? If I plotted these values like this, maybe this is y, this is x, and I had plotted my values they were all done. Now the next thing that I do, I bring this M, I plot this M. This will be a new figure. So if I plot it and it's maybe here, that's where it is. Then I draw a line parallel to the y-axis. This is my y-axis. I draw a line moving like this, moving downward. Now what is going to happen is that the values that are on the left, that are on your right, the values on your right hand side will be equal to the values at your left hand side. The right hand side values, will be equal to the left hand side. The reason is very simple, is because we plotted the mean, and mean dissects, it's always in the middle. Now, what we are going to do, we are going to get the mean of the x value, because we have dissected this graph, and the points this side are equal to the points this side. Let's assume that this is point A and this is point B. Now what we are going to happen, we are going to get the mean of left hand side and then the mean of the right hand side. So we get the mean of side A for both x and y. Then we also get the mean for B, that is for both x and y values. That is what is going to happen in the step number 3. So step number 3 is you find the mean of the left hand of the points on the left. Of course, once you get the mean on the left and then the mean on the right, you plot those two coordinates, and then you draw a line meeting the first mean that you got which was our general mean m, you connect it with the mean on the right hand and then the mean on the left hand. You draw a line, and that line will be the one that we call the line of best fit. So the first key point is to make sure you find the mean, the general mean for the two values, and then you plot it. Once you plot, you ask yourself, what am I dealing with? Am I dealing, do I want to predict the dependent variable from the independent, or am I predicting y from x? If so, I have to draw a line that is parallel to the y-axis. If I'm determining an x value from y, then I'm supposed to draw a line that is parallel to the x-axis. In other words, I'm going to draw a horizontal line. And then I find the mean above the horizontal axis and the mean below the horizontal axis for both values of x and y. What I do after getting those values, I get the mean, I plot the mean of the left and then the mean of the right, and I join those 3 points to form the equation of the straight line or the line of best fit. So you can use the same equation that we have just seen up there. For it, it may not give you, because the values were 5, the number of observation were 5 observation. But it is okay. Still you will get the line of best fit. That's why when I've been explaining, you find that one of the importances of regression analysis, that it helps you to find the mean. This is what we've been talking about. I hope you have understood. If you have not understood, please rewatch the video so that you can be able to get the aspect. Maybe to internalize the other one, if you are finding x on y, instead of drawing, maybe that one, I'll talk about it when I'm about to get done. So step 3, let me write these steps. Let me even change the color. Step 3, we find the mean. Let me call it m left of the points. These points are both for x and y. Points on the left. Let me say ml for x and then y. Then step 4, you find the mean mr. Now this is mean on the right hand side of the points on the right side. Points on the right side. That is mr being equaling to x bar and then the y bar. They are both values. And finally, when you are done, you plot the fifth step is for us to plot. The fifth step is to plot m left and m right on the same graph. on the same graph. Then finally, you join the points. You join the points M left and then M right. You draw a straight line connecting those 3 points to form the line of best fit. So we've said that the last step as step 6 is for you to connect with a straight line, the points M left, M right, and M to form the line of best fit. And of course, when you are predicting X on Y, instead of drawing the vertical line, you draw a line that is horizontal, like this. After plotting that M, this is the M, you draw a line that is horizontal. It cuts across all these values. What is this side will always be equal to what is this side. And this side we call it above, this is below. Then you get the mean of the values below for both X and Y values, and then those ones above, then you join. This point can be here, and maybe another point, let's say, is around here. You connect. When you connect, they will form a straight line, and that straight line will be the one that we call the line of best fit. So that's all that I wanted us to talk about. So you get a question, and then you go through. You can use the same previous question that we looked at, then you draw a line of best fit. Please do the number so that you can understand. So one thing that I wanted to focus on that I had forgotten in regards to correlation, the topic that we finished, we forgot to talk about Kendall's rank correlation coefficient, but it is very easy. I'll create a video. If at all we get some time to fix it and we sort it, we create a single video that is handling the Kendall's rank correlation. Then if time doesn't allow us, then we shall do it under revision, because we are going to have revision classes and we are going to focus on each and every question that we have, so that we can be able to move ourselves very fast and equip ourselves with the information that is necessary for us to pass.